Hi, welcome to myprojectbuzzer.com. Now we are going to see the process of building a scalable system for Stealthy P2P-Botnet detection. Let's move to abstract. Peer-to-peer botnets have adopted by bot masters. This paper proposes a novel scalable botnet detection system capable of detecting stealthy P2P botnets. Our aim at detecting all ghosts within the monitor network that engage in P2P communications. As the volume of network traffic grows rapidly, the deployed detection system is required to process a huge amount of information efficiently. The parallelized computation with bounded complexity makes scalability of our system and also provides high detection accuracy and great scalability. And also we analyze raw traffic collected at the edge of the monitor network and apply a pre-filtering step to discard network flows that are unlikely to be generated by P2P applications. We first apply a flow clustering process. The distance between two flows is subsequently defined as the equivalent distance of the two corresponding vectors. Two P2P paths in the same botnet should have small distance and thus are connected at lower level. In contrast, legitimate P2P applications tend to have large distances and consequently are connected at the upper level. Let's move to see the DFT process. Peer-to-peer networks monitoring the network traffic. The traffic filter component aims at filtering out network traffic. P2P clients usually contact their peers directly by looking up IPs from a routing table for the overlay network rather than resolving a domain name. This is accomplished by passively analyzing DNS traffic and also identifying network flows whose destination IP addresses were previously resolved in DNS responses. Fine-grained detection of P2P clients is responsible for detecting a P2P clients by analyzing the remaining network flows after the traffic filter. The distance between two flows is subsequently defined as the equivalent distance of the two corresponding vectors. We then apply a clustering algorithm to partition the set of flows into a number of clusters. Coarse-grained P2P path detections paths are malicious programs used to perform profitable malicious activities. They represent valuable assets for the path master. Try to maximize utilization of paths. This is particularly true for P2P paths because in order to have a functional overlay network, P2P applications is determined by users, which is likely to be transient. It is worth noting that some users may run certain legitimate P2P applications for as long as the machine is on. Fine-grained detection of P2P paths. This component is to identify P2P paths from all persistent P2P clients. We leverage one feature, the overlap feeds contacted by two P2P paths belonging to the same P2P botnet is much larger than the contacted by two clients in the same legitimate P2P network. Two P2P paths in the same botnet should have small distance and thus are connected at lower level. In contrast, legitimate P2P applications tend to have large distances and consequently are connected at the upper level. Evaluate the performance. A high churn rates affect the performance of P2P networks significantly, causing routing failures, loss of stored resources, and inconsistency. They may even lead to a complete disruption of overlay network. In addition, path masters would also reduce the number of peer IPs contacted by each path to bypass the fine-grained P2P client detection component. Let's move to see the project demo process. Building in our project package name, same as the source package name. Building home.java is the first frame. Select the frame and right click to run file. The frame can be loaded. Click here. Next frame will be open. Here this can be used for to select the peer range and click peer list. Peer range can be displayed here and click process. Next frame will be open and click IP course name retrieval. DNS extracting please wait message will be displayed. Click OK. This frame is to retrieve the each and every peer ghost addresses in the network, and finally display the message box. Click OK. Then apply DNS conflict. Click DNS traffic filter configuring. Please wait. OK. There are analyzing steps for DNS filter, and enable the checkbox and click next to performing the IP filtration. Extract these are the IP addresses for peer list, and apply DNS conflict to resolving the IP evaluation. OK. Then IP filtration eliminate the resolving IP addresses. OK. And finally view the result. These are the elimination IP addresses. Next, and view the filter list IP addresses. Traffic DNS filter extracted successfully message will be displayed. OK. Then process. Here to finding the equivalent distance for every peer IP addresses. Apply equality distance successfully calculated. OK. So distance values. Distance will be displayed here for every IP addresses. Then process. Here to forming the clustering, and click cluster. Clusters evaluated message will be displayed. OK. Then click cluster node. Cluster position verified. 3 clusters can be created here, and select cluster 1 and apply fine grain detection, and select cluster 2 and apply fine grain detection, and select cluster 3 and apply fine grain detection. All 3 clusters fine grain detection of P2P clients can be cluster formation will be listed. Then process, and finally apply grouping. Grouping applied. OK. Here to right click to select the anyone IP addresses, and here this frame is used to finding the nearby surrounding nodes. Select surrounding nodes. Nearby surrounding nodes find and message will be displayed. OK. Then view the neighbor list. Neighbor node selected successfully. OK. Then process, and select the packet. Click choose packet, and select our project path. Select the content.txt file. Then open. View the packet contents. Then process, and select any one peer in the list box and send the packet for peer 1. Packet sent to 50.18.104.27. OK. Then next to run the p1.java frame. This frame is receiving the packet. Click receive packet. Packet receive is displayed. OK. Then finally send the acknowledgement. Click here and open the final frame. Files and message will be OK. Then finally click receive format. IP addresses receive the packet successfully, and then select the next peer and send packet for next peer. OK. Then next to run the p2.java frame. Here to receive the packet. Packet received. OK. And send the acknowledgement p2, and receiving files and message will be OK. Then go to p2 frame and receive format. These are the second peer receive the content.txt file, and next to again select next peer, send packet. Packet sent to the peer. OK. Then p3.java can be run. This frame is receive the packet. Packet received. Finally send acknowledgement and view the next frame. Files and OK. Then receive format here. And finally select the final P and send the packet. Again packet send, then go to run v4.java frame, run file. Packet can be received here. Packet received and send the acknowledgement to frame. On open it, click OK, then receive format, and finally go to the timestamp evaluation frame and click packet format. These are the packet can be received for every peer. Then calculate time. Click calculate timestamp. This time will be calculated for every peer name, and then go to peer evaluation. Here to evaluate the distance for every peer. Peers evaluated. OK. Then bot detection. These are the lower level peers, and legitimate weights display the upper level peers. Then go to assessment. For execution time will be evaluated here. These are the P2P part identification and legitimate P2P client identification, performance, transaction percentage, and click distance graph for every IP addresses, finding the P2P system in the distance value. Thank you.